So question 63, a bit of fun with a function. So any cubic function which passes through these 3 points is going to have x plus 4, x plus 3 and x minus 1 as factors, as so. But this equation for f of x would go through the point when x equals 0, y would be equal to minus 12. So clearly this isn't the equation quite that we're looking for, but any equation of the form k times x plus 4, x plus 3, and x minus 1 will go through these 3 points. So we're looking to find the value of k. So we do that by saying, well, when x equals 0, y equals minus 5. And when we substitute the values x equals 0, y equals minus 5 into this equation, then we get the value of k equals 5/12. And then, so we can write down the expression for f of x, which is 5/12, x plus 4, x plus 3, x minus 1, like that. But now we've got to draw a sketch of f dashed x, the gradient function. Let's have a look at that now. So when I look at the gradient function, I'm looking at the gradient of f of x, and there's some key points which are of interest to me. This point here, where the gradient is 0. So at that point there, the gradient is going to be 0. And at this point here, the gradient is 0 as well. So if this is the graph of y equals f dashed x, then y is 0 at both of those points. Then on this part of the curve, the gradient is very big and positive. So that means that my gradient function is going to look like this. And at this point here, the gradient is positive. So I'm looking at this kind of shape. And then for the bit in the middle, the gradient is negative. So that's basically the shape of f dashed x. It's a quadratic. And going through those points, which are unspecified, we could actually work them out if we wanted to by differentiating f of x and then solving the resultant quadratic equation and finding the roots of that. But since we're not asked to show the points of intersection with the coordinate axes, that sketch will be perfectly fine. So hopefully you got on well with that question, and if you did, well done.